Hello friends, myself R.D. Mahajan presenting my video on successive differentiation. Let us prove that if y is equal to x divided by x square plus a square, then prove that nth derivative of that term as minus 1 raised to n factorial into cos of n plus 1 times theta. And therefore here given is y is equal to x divided by x square plus a square, making factors of that x square plus a square, we get that factors as x plus ia and second one as x minus ia. Here the factors are imaginary or complex number, and then the degree of numerator is 1, degree of denominator is 2. 1 is less than 2 means it is proper fraction, and is its proper fraction, making partial fraction a upon first factor and b upon second factor, and it is y is equal to x upon x plus ia into x minus ia, and we call this equation 1. And then to determine the values of ab using partial fraction technique, we get the value of a as neglecting the term below it, that is x plus ia, remaining term is x upon x minus ia, and its value at x is equal to, equating this to 0, we get x is equal to minus ia. Substituting that value, we get minus ia divided by minus ia and minus ia, it becomes minus 2 times ia, and therefore the value is minus minus, it becomes plus, ia get cancelled, we get the value as 1 by 2. Then similarly we try to find the value of b, neglecting this x minus ia from this term, remaining term is x divided by x plus ia, and its value at, equating this to 0, we get x is equal to ia. Substituting that value, we get here ia divided by ia plus ia, we get 2 times I into a. This I get cancelled, we get value as 1 by 2. And therefore substituting that values in equation 1, equation 1 becomes y is equal to value of a as 1 by 2 divided by x plus ia, value of b is also 1 by 2 divided by x minus ia. Then we can take 1 by 2 common from this, and then transferring this term to numerator, we have the value of y as 1 by 2 constant outside the bracket, x plus I raised to minus 1 and x minus I raised to minus 1, and then finding nth derivative on both sides, we get yn is equal to 1 by 2 constant term, nth derivative of the first term, that is x plus I raised to minus 1, and plus nth derivative of the second term, x minus I raised to minus 1. And then applying that standard result, we know this nth derivative of ax plus b raised to minus 1 as minus 1 raised to n, a raised to n factorial divided by ax plus b raised to 1 plus n. Compare, we get the value of a as 1 here in both the term, and therefore we get yn is equal to 1 by 2 as it is, no change, minus 1 raised to n 1 raised to n is 1 into n factorial divided by ax plus b. Here it is x plus ia, and that raised to 1 plus n plus nth derivative of the second term. By applying this result once again, we get minus 1 raised to n. 1 raised to n is 1, n factorial divided by x minus ia raised to 1 plus n. Whatever the common term, I will take outside. Therefore, it is 1 by 2 minus 1 raised to n, and n factorial is common. I will take it outside. Then remaining terms are, transferring this to numerator, we get x plus ia raised to minus of 1 plus n and x minus ie raised to minus of 1 plus n. We call this as equation 2. This is the nth derivative containing complex term in the result, and therefore we try to convert this in this required form by using the equivalent. We have x is equal to r cos theta and y is equal to, here y means imaginary term, that is a, is equal to r sin theta. Using this equivalence to convert in terms of polar form, and therefore we get yn is equal to minus 1 raised to n, n factorial divided by 2, as it is no change. Substitute value of x and a. X is r cos theta plus I times a. A is r sin theta, and that bracket raised to minus of 1 plus n. And similarly for the second bracket, it is again x. X is r cos theta and minus ia is r sin theta, and that raised to minus of 1 plus n. From this bracket I can take r common. From this also I can take r common, and while taking outside it raised to minus 1 plus n. Therefore from these two terms I will take it outside. We get yn is equal to, therefore minus 1 raised to n, n factorial, and that common term r raised to minus of 1 plus n, and divided by 2. Remaining terms are, here remaining is cos theta plus I sin theta, and that raised to minus 1 plus n. From this also I can take r common. Remaining term is cos theta minus I sin theta, and this bracket raised to minus 1 plus n. And then we apply one important theorem from complex number. Cos theta plus I sin theta raised to n, by that de Moivre's theorem we get equal to minus 1 raised to n, n factorial divided by 2 times r raised to 1 plus n, this term as it is. Expansion of this by this, it is cos of minus 1 plus n times theta. Cos minus theta is cos theta, and therefore it is cos of n plus 1 times theta sine of I sine of n plus 1 times theta. Expansion of this by that de Moivre's theorem, it is again cos of n plus 1 times theta, and this minus and this minus, it becomes plus I times sine of n plus 1 times theta. This is using de Moivre's theorem. And then if you see here, minus I and plus I times sine theta, these two terms get cancelled, and we get finally minus 1 raised to n factorial divided by 2 times r raised to 1 plus n. It is 2 times cos of n plus 1 times theta. 2 get cancelled, and we get the required result. Yn is equal to minus 1 raised to n factorial cos of n plus 1 times theta, and divided by r raised to, here make the correction, divided by r raised to 1 plus n, and therefore it is divided by r raised to 1 plus n, where the value of r is root of x square plus a square, and theta is tan inverse of y by x. Here it is, y means e, divided by result, nth derivative of y as minus 1 raised to n factorial cos of n plus 1 times theta divided by r plus 1, r raised to 1 plus n, where the value of r is the root of x square plus a square, and theta is tan inverse of y by x. Here y is e, therefore a by x, a required result. I will present my next video on another important point, that is Leibniz theorem. Therefore, if you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you.